السلام عليكم ورحمة الله وبركاته. My dear students, I hope you are all fine wherever you are and safe. Just take the precautions, health precautions, and inshallah everything will be okay. Our lesson today is about thermal energy transfer. This was an E. Our lesson today is about thermal energy transfer. And specifically, the objective will be to describe how energy transfer may take place by conduction. As you are aware, most of you requested we go through this unit. We revise it again, and that's why I chose it. So we will see when we finish. According to the demand of the students, we can look at another topic. But back to our discussion, we said the objective of this lesson is to describe thermal energy transfer by conduction. Now, before we delve into thermal conduction, let us try to understand the big picture. Okay? When you hit an object, let us say you put a spoon in your sauce, your marak. You're heating up this spoon, or you drop something in the fire. Whenever you hit an object, you transfer energy to its thermal energy store, and this causes the temperature to increase. So there is a corresponding increase in temperature. There are three main ways that thermal energy may be transferred to an object, and you can see here we have thermal conduction, which is our topic of discussion today. And we said this usually happens in solids, but some liquids have also shown thermal conduction. We also have thermal convection and thermal radiation. But I will focus specifically on number one. Okay. So take an example. We have this object here, and the balls you are seeing are the atoms. These are the atoms. The brown balls are the atoms, and the whole rectangle is representing a metal. Okay. So these arrows here are showing the movement of the atoms. Actually, it is a vibration of each atom. Now, if you hit the left-hand side, the atoms on this side will gain kinetic energy. And when they gain kinetic energy, they will vibrate more. You see, these arrows showing vibration this side are bigger than these ones, these blue ones, this side. So there is an increase in vibration of the particles. In this case, the atoms. So when these atoms vibrate, let us consider this one here. When it moves further, it will collide with the next atom. In so doing, it transfers some of that energy to this atom here, Then this one also gains kinetic energy. It vibrates more, collides with the next, transfers that energy, some of its kinetic energy, to this one, and the process continues. At the end of it all, the energy which was supplied to the left hand side, this side, will have reached here through the vibration of the particles. Okay, so this is an example of thermal conduction. One molecule gains kinetic energy, collides with the next, transfers some of the kinetic energy to the next. The process continues until the whole object is uniformly heated up. So what we are saying here is that conduction is the main method of thermal energy transfer in solids. That's point number one. Then when a material is heated, the atoms start to vibrate more. They were vibrating before, but they vibrate more and collide with one another, transferring energy. These are examples of inelastic collisions. So thermoconduction, here is our definition for thermoconduction, is the transfer of heat energy through a substance by atomic vibrations or free electron diffusion without the net movement of the material. If you look at this definition, we are saying heat is transferred by atomic vibrations. I've explained that here. But you will find that some materials are better thermoconductors than the others, especially metals, due to these free electrons. They speed up the process because they are free to move. So they speed up the process of conduction. We'll be discussing that later. And then another thing about thermoconduction is that when it takes place, the material through which thermal energy is transferred does not move. As you can see, when you hit the solid, it remains in the same place. The solid doesn't move. So there's no net movement of the material medium. So we're talking about atomic vibrations, free electron diffusion, and no net movement of the material. So thermoconduction, as the definition says, is the transfer of heat energy through a substance by atomic vibrations, free electron diffusion, and the material medium does not move. Okay, so briefly we will look at nonmetals here. Let us say these are atoms. They are held together by bonds. These broken lines, black, are the bonds. So when you hit this atom here, there is an increase in its kinetic energy, vibrates faster, and then collides with the next, transfers some of its energy to this one, and some of its energy to this one. Then these two also continue. In the end, the whole nanometal will be heated up uniformly, will be in thermoequilibrium. So eventually, the energy spreads through the solids and the overall temperature increases. When we are dealing with metals, in metals there are some free mobile electrons. These ones here represented in green. So when you heat, just like before, even these electrons are heated up and they move even faster, moving around here. So the process of heat transfer speeds up. That's why metals are better thermoconductors due to the presence of these free electrons, and they speed up the whole process. It happens much faster than in nonmetals. Okay, then we need to bring in the concept of thermoconductivity. This is a measure of how well a material conducts energy when it is heated. Thermoconductivity. So you find that some materials are better thermoconductors than others, and the material which has a very high thermoconductivity, we can just call it a thermoconductor. Those that have low thermoconductivity, we can call them thermoinsulators. And you have these examples. Now, to compare the thermoconductivity of different materials, a setup like this could help. There are different setups. If you check your textbook, you will find different setups. But this will suffice. As you can see, we have a tripod stand, and 3 different materials are placed on it, creating a junction here which is heated by a Bunsen burner. So you expect that if maybe you attach small balls here using candle wax, the one that heats up faster at this right hand end, this side, will be the best thermoconductor. You see? So you could compare thermoconductivity by considering how fast the whole thing heats up. Okay. Now there is a question here, and you have to look at this table carefully. You see copper, its thermoconductivity in watts per meter per degree Celsius is around 385. Glass 0.17, brick 0.15, and air is 0.024. This table tells us something very important. The first material is a thermoconductor because its thermoconductivity is very high. And this is the worst thermoconductor in that table, air. And it's very important for us to know the properties of air, especially if it's still air. When it's trapped and it's not moving, it's one of the best thermoinsulators. And many exam questions will test you on the properties of still air, trapped air. So you need to know that when you trap air, it's not moving, then you have created a very good thermoconductor. Okay, and houses use this property. Even you, when you cover yourself in the bed, you are trapping air, which acts as a thermoinsulator, prevents heat loss from your body, and you remain warm. That's why we cover ourselves in the night. So it's a very important property, and you'll be tested a lot about the insulating properties of air in the exams. Now let us look at this question. It says, referring to the table of conductivity above, why is it better to have a window made of 2 layers of glass? You see, it's double glazed. You have a piece of glass and another one, 2 pieces of glass. And these 2 pieces of glass, it's a double glazed window. They always trap some air between them. So there's some air here. See? Air is trapped here. So when air is trapped, you have a good thermal insulator which minimizes heat loss from the building. Similarly, the glass is a thermoconductor on its own, so it will also minimize heat loss from the building by thermal conduction. So the combination of these two things, the trapped air and the glass, help to minimize heat loss by thermal conduction. So here the question asks why it's better to have a window made of 2 layers of glass with a layer of trapped air between them. So we are saying both glass and air are insulators because they have low thermal conductivities, and this reduces heat loss by thermal conduction. But also we know that air and glass are transparent, so we need a window that is transparent, so that may also be a reason. Okay, and then we have these questions here, a quick checkup. I would like you to try them. Just get a piece of paper and a pen. You write the questions. Just write number 1, 2, 3 up to 6, and then you try these questions. I think I can give you some 2 minutes to do that. So you can start with that. Number 1 is finished. Which is the best insulator? Number 2. Why is loft insulation so effective? In the buildings, at the ceilings, they put some insulating material. Why is it so effective? All these things trap air, so it's testing the insulating properties of air. Number 4, and 6. So let us check if our answers are right. Yeah, number 1 is A, number 2 C, 3A, 4B, 5A, and 6B. If you have any questions about these answers, you need to clarify something, feel free to write a comment at the bottom. I'll be able to respond with the necessary haste. Now, here is a typical exam style question. And also, I will want you to try it. You can just brainstorm about it, but you need to try it. And see, testing the insulating properties of air. So we're told penguins are adapted to survive in cold conditions. You can see these very beautiful birds. The adaptations help them to maintain a constant body temperature. Penguins also crowd together, so they have body features adapted for cold conditions. And also when they come together like this, they minimize heat loss. And I think you already guessed it. When they come together, they trap some air between them. This trapped air is a thermal insulator, so it minimizes heat loss by thermal conduction. keeps them warm. See, insulating properties of air. Many exam questions will test you on that. You need to pay a lot of attention. So what the student decided to do, he wants to investigate how the temperature of the penguin is affected when they crowd together in groups. So this is the setup. The student decides to tie together some 7 test tubes to act as the penguins, and 1 test tube to act as a single penguin. Okay, so in this investigation, the student wants to see which of these 2 settings will the temperature drop faster. Of course, when there is a bigger drop in temperature, it means there's bigger heat loss to the surrounding by thermal conduction. Okay, so student sets up this. And here is the possible procedure. You need to order the steps. Step 1, step 2 has been done for you. Step 3, 4, 5, fill in, these steps. If you are to carry out that investigation, how would you do it? So try to answer that question. Then this part is easy. You need to find the temperature at different times. So you can see that here the units are missing. Okay, and this is time. And then here you must write the other physical quantity, which is temperature. But of course, with units, we have 2 different setups. You have to clarify for a single test tube and for 7 test tubes. So you fill in that table. Then you're asked to predict the temperature change for the single test tube, how it differs. I won't answer that, but then here you draw a graph of the results. So first thing, you can see that the axes are not labeled. So you need to label the axis. Put the dependent variable here, independent variable here. Once you do that, you need to sketch your graphs. You should know that these are cooling curves. So as you know, a cooling curve starts on this axis and drops until it reaches 0. Because this is a very cold place, you could reach 0. If it's here in Hargeisa, this should not touch this axis, because we never reach 0 degrees here. So maybe we stop at around 20 something if it's here in Hargeisa, but these penguins are in cold places, so you could reach 0 degrees. So you need to take this up to the x-axis, the horizontal axis, sorry. And then you have to draw the cooling curves for the 2 and differentiate them. One of them cools quicker than the other. So you need to know which one is for 1 test tube, which one is for 7 test tubes. And then here you need to explain in terms of conduction, trapping of air, thermal insulators, that kind of thing. Try to answer these questions. Just giving a hint, you could complete, and then you're supposed to hand in this work to your parents, and then I'll look at it when they present. They also have layers of fact and flat